Okay, maths fans, here we go. On to equations 2 with the next round. So, without further ado, let's get this show on the road.
We're going today, here we go. Working all over the world.
I like it, I like it, I like it, I like it, I la 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 like it, la 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 like it, we go.
Working all over the world.
Yeah! So we're rocking today with equations 2, and we're going to take this one level further. Okay, so without further ado, let's get cracking on this. So before we start, I've just come up with a little physics issue here that I found. So in physics, we've got V equals IR. Famous equation, V equals IR. So the question is, how can I manipulate this so that I can find I on its own and R on its own? I'll just give you a moment to think about that. Okay, so one thing to remember from yesterday is that whatever function you do to one side, you need to do to the other, and that way it balances around the pivot point, and the pivot point is always the equal sign. So if we get to look at this carefully, we've got to find I on its own, we've got an R there. Now what's happening between the I and R? It's actually a times. Okay, so when two letters are together, it means they multiply together. So I want to do the reverse of this times by R, and by doing that, I'll be able to cancel those out, and so I can get I on its own. And remember that we're working downwards, not left to right. So let's see what the reverse of times by R is. That's going to be divide by R. So if I do a divide by R on both sides, let's see what happens. So if I do a divide by R on this side, I've got a times R divide by R. Well, that just cancels into a value of 1, which 1 times a number is the same. But I've got to do the same thing to the other side, and that's a divide by R. So that's going to be V divided by R, and to show division, we write V over R, and that gives us I. Okay, so actually it's really quite easy. Now let's go back and find the R as well, because that was part of the question as well to get us started. So go back to the original equation. Okay, and this is exactly the same process as what we just learnt. So we want R on its own now. So therefore, what I've got to do, I've got a times by an I. So I've got to do a divide by an I on that side, an I times and a divide by I. They cancel, and then I've got to do the same thing on the other side. So we end up V divided by I, V divided by I equals, I's cancel there, so R's there. And that's it really. So whatever you do to one side of the equation, you do to the other to balance things out. So let's go back to yesterday. So we managed to do a couple of these questions. So I'm going to whiz down to this question here now. Okay, it's just a little bit of a recap, okay, to get things started. So remember that the balance point of a scale or the system, that corresponds to the equal size. Okay, so bear with me on the focusing. Again, we talked about that. This is the best focus I can get today. It is an issue, and I will be looking into investing in another camera at some stage, but for now we'll crack on with this. So we've got an E plus 3 equals 27. And we talked about yesterday, solving equations is actually finding the value of the missing letter. So the missing letter is actually a number. So this letter here, E, is a number. So something add 3 is 27. Now we want to be looking at the mathematical concept of this, not just thinking, right, what add 3 makes 27. So thinking about the mathematical concept, we've got to get E on its own, because that's what it's all about solving. So what I need to do is think about what am I going to do to this side so I've got E and no numbers. It's got to be the reverse of this, plus 3. So if I've got a plus 3, I need to take away a 3. But the thing is, I've got to do the same thing on both sides. So this cloud here and this cloud here have got to be the same. So I'll put a minus 3 in there. So plus 3 minus 3 gives me E. 27 minus 3 is going to be 24. And then, as we discussed yesterday as well, a good idea is to take this number here and put it back in the equation, 24 plus 3, and just check it's correct. So what's happening here then? We've got a 2f is 22. So this is one of those ones where we did yesterday, where we're going to split the letters in two halves. So 2f means an F and an F, two lots of an F add an F. So an F add an F is 22, but the F's have got to be the same here. So again, the same sort of idea, what's going on. If I've got 2 times an F, I want 1 F, so I need to do something with this 2 times. So I'll give you a little think. I'll just put that in full so that we can see it a bit more clearly. We've got 2 times an F is 22. So what am I going to do? I'm going to do the reverse of a 2 times. Okay, give you a second to think about that. What's the reverse operation of as 2 times? That's right, so I need to do a divide by 2. A divide by 2. So a 2 times and a divide by 2. Okay, they cancel, giving us 1F. But I've got to do the same thing on the other side. So that's a divide by 2 there. So 22 divided by 2 is 11. So F is 11. Okay, brilliant. And likewise, just jumping down the worksheet a little bit more, we've got this situation here. Similar idea. N divided by 3, that's a divide, equals 8. So thinking about reverse operations, okay, we've got a divide by 3, so the reverse of that's going to be a times by 3. Okay, and we've got to do it on both sides. Okay, so that means that a divide by 3 and a times by 3 cancel, leaving n on its own. Okay, but I've got to do the same to the other side, so that is 8 3s are 24. Brilliant. Okay, and the last one on this sheet, something to think about, is this one here, s squared equals 100. So thinking about what s squared means, that means an s times an s. S squared equals 100. So what we need here is a number that times by itself makes 100. Or we could possibly think of the reverse of a square. Have a think for a second. What would be the reverse of a square? Okay, so it's a square root. Square root. So we need to take the square root of both sides. The square root of an s squared is going to leave us with an s. And the square root of 100, what times itself makes 100? That's actually nice and easy. It's going to be 10. Okay, so that's that worksheet. Now, what the thing is with these equations is that you're not going to get a question at GCSE with a nice looking balance like that. Okay, what you're going to get is just the top bit. Now actually, take that one for example. You're just going to have n divided by 3 equals equal. No nice picture, no balance. Now actually, the more I do maths, the more I teach it, I think that if you actually made a balance in a GCSE, there's absolutely nothing wrong with that. And you can actually draw this sort of thing out very, very quickly. Okay? But if you get good at these, you soon realise that actually the next step is to drop that balance. Now I'm not saying you have to, okay? What I am saying is that that would be the next step on. So that's what today's lesson is about. It's about taking that next step with this concept here of what you do to one side, you do to the other. Once you've got that and you know that it pivots at the equal sign, and if you take something off or add something on, you've got to do the same to both sides for it to stay balanced. Once you've got that concept, all we need to do is apply that idea to the actual algebra we've got. So jumping on to this sheet here, this is what we're going to be working on today. Okay, again, it's not that clear, but what we can do is we can, I'll go over the questions. We're not doing all of this sheet. I'm just going to pick a few to really think about and focus on, just to get us thinking. So the first one is this one here, 3x equals 13. Okay, so with this 3x equals 13, thinking about this being our balance point, okay, and as I said, there's no harm in creating a little set of scales there, but actually from there we need to be able to get the answer. Okay, so let's just take a little commercial break, okay, and I want to just remind you of something going on. Look at these expressions. Have a look at those. Okay, so what we're thinking about here, we're not thinking English here, thinking oh ab, cub, or could, all that kind of thing. What we're thinking about is what's going on. So first of all, a and b are numbers. We don't know what they are, but they're numbers. So a times b, okay, is straightforward. So if I've got a equals to 2 and b equals to 3, what's going on in the first one is 2 for a times b, 3, 2 3s are going to be 6. Okay, so that's what's happening there. This next one, AB. And this is the important concept I want you to remind you of. Letter next to a letter. It's exactly the same thing as what's happening up here. Okay? It means times. Two letters next together means times. Okay? So we would get the same number if we substituted in the 2 and 3 that I'm just making a suggestion for. Again, another idea here, CD, what's going on? We don't know the values of CD, but we can actually figure out what would be going on with these two numbers. And that would be whatever number C is times whatever number D is. Again, a letter next to letter, we always put a times in. What about this one, 4A? Brilliant. Same idea again. They're both letters. It's exactly the same idea as all of these, except that's a number. So we've got that already. That's not going to change. Okay, that's called a constant because it's there all the time as 4. This one is going to be a number still, but that's going to change. So that's going to be an A. So we've got 4A. Given the fact I've given you A equals 2, we can actually work that value out by replacing A with 2. And we get an 8. And the final one, again, same idea, 5EF. So that's not a little word, F, 5 Fs, okay? It's 5 number E, number F. And again, in maths, we like to drop the times and put, and each, in between each one, we should have a times there, but we drop it, okay? And we haven't got an EF value, so that's all we can do, 5EF. They're the same thing. What I'm pointing out is numbers next to letters, letters next to letters, we need a times in between them. Okay, that is one thing that mathematics teachers, mathematics people like to do. They like to minimize the amount of work they're doing. So therefore, taking the times out, I know it's a little bit confusing, but convention-wise, they like to shorten it. Actually, it's quicker if you get used to it. Okay, so going on to some of these questions then. 3x equals 13, the first one. So now we've just learnt that 3x means 3 times an x equals 13. And thinking about doing the reverse process, what we need to do is divide both sides by 3. Let me just get some more paper here for working out. 3x equals 13. So what I want to do is do the reverse of this, and that's a times, 3 times x. So I want to divide by 3 on both sides. Okay. So 3 divided by 3 is 1. So I've got 1 of the x's. And 13 divided by 3 we can write it like that because it doesn't work out totally, and this is called an improper fraction. We can get a mixed number from that, and that's 13 shared by 3. 4 3s are 12, so we're going to have a 4 and 1/3 left over, so 4/3. But actually, unless the question specifies a mixed number, it's okay just to leave it like that. Just read the question how the answer should be. So that's the first one. Jumping on to this one here, probably better off writing it out on plain paper so we can see what's going on. X divided by 3, remember that's a divided or out of, equals -6. Now what people often do here as a misconception is they go, oh, that's a divide by 3, so I'll do a divide by 3 there, x equals -2. But you know what? The thing is that we're not dividing by 3 on the other side. We want to do the reverse of what's on the left hand side. So if I've got a divide by 3 and a divide by 3 again, that's x divided by 3 divided by 3. That's not going to get us x on its own, which is what we want. So what we need to do here is we need to do the opposite function, and that's going to be a times by 3. But we must do that on both sides. So a times by 3 and a divide by 3 cancel, and then I've got a 6 3s are 18, 6 times 3 is 18, is -18. So x equals -18. Okay, don't worry that it's a negative, the same principle applies. All as we've done to get x on its own is the reverse function here. We've got to divide by 3, so a times by 3. And what we do to one side, we've got to do to the other. 6 3s are 18, that's it. Okay, so sticking to that rule, what you do to one side, you do to the other, you can solve any equation whatsoever. Okay, quick pause. This answer, is it -18 or -18? Now this one is really for Mr. Griffiths, but I'll give you a second to contemplate the correct way of saying that answer. Boodle-doodle-doo. Okay, so your time's up, and what you find is the correct answer is negative. Okay, and the reason is the word negative is a noun, a name, and this is a name of a number. Minus is a doing word, which is a verb, so therefore minus, we're not doing anything here, so we don't use the term minus. There are lots of places where we use the word minus. The way I remember this is negative begins with an N, so we call it noun. It's highly unlikely that you're going to get marks knocked off by saying minus. Many teachers won't even stop you for that, but we're trying to be professional mathematicians here. Okay, one more question, and then I'm going to leave it for today, and there will be an equations 3. So let's have a quick look at, we're not going into brackets yet, that's tomorrow's, but let's have a quick look at this question here. 5x plus 3 equals -4. Now this could be on a GCSE, anything up to intermediate. Certainly on higher, it's probably likely to be mixed in with an equation somewhere else, but this is a two-step process because we've got a times by 5 and a plus 3. So which one should I go for first? Well, actually, it's a bit like BIDMIS, only backwards. Okay, so imagine doing reverse processes. You don't want to do the brackets first in this case, or addition, or multiplying. You want to leave them till the end. So where you start on this is you think, right, I'm going to start here, so I've got a plus 3. You don't want to divide it by 5 because you'll have to divide the whole thing by 5, and that's going to cause more problems than it's worth. So you save that divide by 5 till the very end. So first things first, this plus 3 is in the way because we need just letters on one side, numbers on the other. Okay, so we need to get rid of that plus 3. So the reverse process of a plus 3 is a minus 3, and we need to do a minus 3 on both sides. Okay, so plus 3 minus 3 is 5x. and then I need to do the minus 3 on the other side. Now don't be confused about this minus and minus business. The signs are not together, they're not multiplying, so we don't need any of those rules for this part. Just a simple number line. Okay, I'm starting on negative 4. Okay, I'm taking away 3, so I'm counting that way. Negative 4, negative 5, negative 6, negative 7. 1, 2, 3 places, so that's negative 7. So it's only when the signs are together we start thinking about those rules for minus and minuses, a plus and all that kind of stuff. I know Miss Jobson's brilliant at explaining that using counters and stuff, so if you're stuck on that, perhaps we can put a video up later on about negatives. Okay, so remember, look at that equal sign. Okay, trying to keep it in line as best you can. It helps, it's neater. Okay, again, you're not going to get marked down for it, but it's just a nice thing to do because that is your balance point. And the last thing here, we want x on its own. So what have I got here that's getting in the way? I've got a times by 5, so I need a divide by 5 on both sides. A 5 divided by 5 gives me 1x. 5 divided by 5 is 1. Remember, we don't need the 1, but we can put it in if we want to. Okay, so I need to do the same on this side. Minus net, I've just done what I've said before, minus negative 7 out of 5. Okay, so I'm left with x is negative 7 over 5, and I can leave it like that. There's no reason why I should change that answer. Okay, unless of course the question answer specifies that. So that's my final answer. Negative 7 over 5 is x, working down. Okay, a little bit untidy that is, but we're getting the right idea. Okay, remembering the system, what you do to one side you've got to do to the other at each stage, and the thing to remember here is just get all your letters on one side and your numbers first. That's the first step, so don't bother with that divide by 5 until right at the end. Okay, sort out the plus 3 first and you're sorted. Okay, so that's it for today, folks. I'm sure Mr. Griffiths has got Mice and Men going on. What could be better for a day of home tutoring than Equations 2 and of Mice and Men? So tomorrow, folks, we're going to be having Equations 3, and then we're going to be looking at some work on brackets, putting brackets in there to go with everything. Okay, so these videos again will be on YouTube. I think Mr. Griffiths is uploading them onto SoundCloud, and they'll be available for you to watch time and time again if you so choose. But yeah, pass it on as well. I want to go viral. Mr. Donlon's Maths viral. It's a lot better than Mr. Corbett, and it is getting out there. So, without further ado, we're going to have a bit of status quo, rocking all over the world. 3, 2, 1. Try that again. 3, 2, 1. All over the world.